figured is just go ahead and tell us a little bit about yourself and what your area of study is, or areas of study.
Well, let's see. My name's Bob, and I'm a semi-retired physician. Got my degree in biology and, of course, medicine. Practiced for many years, and now I'm kind of semi-retired and mostly working with science and science outreach. I have a backyard observatory that rivals many universities, and I'm thinking seriously about going back to school to get a master's in astrophysics and become the high school teacher that nightmares are made of.
Well, why nightmares?
I'm going to be one of those guys that's going to want to sit down and you're going to learn this stuff, man. And I'm going to figure out a way to make you learn it.
Yeah.
You know,
Well,
I will find that little key that unlocks that little light bulb in your head that gives you some understanding. And I do the science education on YouTube mostly as practice for that. And I've been pretty successful with it, I think. I just enjoy it. I enjoy being a science communicator. And I don't know, people tell me I have a knack for it.
yeah. Well, that's good. I myself am a science teacher. I have a degree in biology, but I've taught all the sciences. I'm currently teaching chemistry at the moment. But I would have guessed because I I didn't know very much, but from what I heard, all the flat Earth debunking and um, the observatory and all that, I would have guessed something along the lines of like you had a degree in physics or something like that. But that's cool. So you're sort of self-taught with the with
Well,
the
no,
other
I
stuff.
studied physics in college,
Well, true.
and my dad's an engineer. My whole family's engineers. I ended up going this route, but yeah, I've learned from a lot of the best, and I try and absorb things quite well, and I seem to have done that.
It seems to be working. Yeah, yeah, I can agree.
Yeah.
So with your with the kind of science communication that you do, would you say that for the most part what you do is debunk flurfers, or do you kind of just do? Is that just kind of a small part of it, but it gets a lot of attention, or what would you say?
Well, for the last 5 years, I started off in this field because I saw a flat Earth video that said planes had to dip their nose in order to fly around the curve. And as a pilot, I figured, well, I'll get a little model and I'll show them how this works. And, because this is something that I do, that'll put an end to it. Well, actually, that's when the fight began. And 600 videos later, I've kind of become a nightmare to them. But, I kind of got stuck into a rut over on YouTube where I was doing flat Earth debunking. And quite frankly, I'm not really excited about it anymore. I've already addressed all of the arguments several times, come to the conclusion that flat earthers simply are incapable of learning because they always ask the same question again, but they never bother to listen to the answers. So, I thought it was kind of a waste of time. So I kind of transformed a little bit. Not only the science education, I'm kind of looking at the psychology of science denial and these conspiracy theories. And, like I did with Caleb the other day, I'm not really interested in debunking somebody that thinks the earth's flat. I'm more interested in why they think that's a legitimate opinion to have or a legitimate point of view. What happened to them to cause them to go down that route? And that's kind of what interests me right now.
That's really fascinating because I that's what I try to focus on too. I'll give the arguments for how we know the Earth can't be flat. I mean it's not even hard to do. You can just look at the angle that the North Star is in the sky, for example, is a very simple one to do. But I very much try to focus on what people are saying, why they're saying it, and how they got there. So I try to break down
Yeah.
the logic of what they're saying in a lot of my live streams and debates as well. So I think that's cool. And the psychology of it interests me too. I've
Yeah.
read some books on a lot of it's kind of like along political and religious lines, but that kind of thinking spills over into a lot of this other stuff. Flat flat earthers, although they say they hate the government, they tend to have very like right wing Christian views at the same time. So that
While cashing
tracks.
their government checks. Yeah.
Yeah, yeah, yeah.
Yeah, they hate the government. They hate the government. They hate government services that other people get, is what they, it's a very specific thing. But, so on TikTok, I decided I really wasn't going to do any debunking. So what you will see over here is me dissecting the arguments, and you will also see me doing the science that allows you to actually debunk these things. And, like I do it myself. I've personally measured the curvature of the earth in my backyard. I have a half-mile long lake. I've measured the rotation of the earth. Um, I'm going to be doing Earth, Moon, Earth bounces to measure the distance to the moon using ham radio. Tonight, I tracked the ISS and verified its position and speed. These are things that I can do. I'm capable of doing here. And, this is good information. I've got a couple of videos coming out this week that, are not there necessarily to disprove the flat earth. It's there to just demonstrate the fact that, this only can occur on a spherical earth.
Yeah,
And,
yeah. It's the
you know,
observations we make preclude a flat Earth in
yeah.
every way. Yet they still come up with things to say. Have you been the target of flat earthers? I didn't even realize this,
Yep.
but there are a couple of flat earthers that have been making videos about me on YouTube for months, and I had no idea until only a couple of weeks ago.
Oh, yeah, all the time. Um, Not only have they made videos, they've threatened to have me shot.
Oh yeah, yeah. I've been I
They've tried to dox me. They've published my office and home address.
Wow.
Things like that. This is the type of community that you're dealing with. These are the type of people.
Yeah,
So when
they're
you destroy them, they strike out like petulant children,
yeah, they're not quite
and
right.
it's kind of fun.
Are there any of the sort of well-known ones that you think are actually full of shit? They don't even believe what they're saying. I've had a lot of people tell me that Nathan Oakley doesn't think the Earth is flat, and I kind of
Eh,
I've listened to very little of him because I don't have the patience and I don't care. But from what I've heard, he really sounds like somebody that doesn't believe what he's saying.
Oh, of course he doesn't. Do you know Ranty Flat Earth?
No.
Ranty was a really big flat earther, made a lot of videos and such, that had a come to Jesus moment and realized that this was all crap. He was in the inner circle there. And he came on out and said, "These guys, he's talked about it. These guys know full well the earth isn't flat. It's Nathan Oakley is a trained actor. You know that, right? That was what his degree in was theater.
I
He's a
don't know
voice
very
actor
much
in the
about him,
UK.
but yeah.
Yeah, he's a voice actor in the UK, and he's trained in theater.
Oh man, he's got a.
But
I can't
this is
stand listening to him. The fact that he's a voice actor, that's funny.
yeah. But typically, what they do is they come up with a persona, and then they promote it, and then people throw them money. There are two types of people in the flat Earth. There are those that sell T-shirts, and there are those that buy them.
That buy them, yeah.
And they are T-shirt sellers, and that's all they do. You know, all flat earthers are dishonest, if only to themselves, and some are a little bit more dishonest than others.
Hmm.
And I've just kind of broken them down into a few tiers. There's your top tier flurf daddies, and then your second tier. Your second tier, and then your third tier. The second tier kind of the Flurf Daddies kind of come up with the ideas like this big thing about, quantum eraser and his, we have to use my scientific method or else it's pseudoscience. He's the one that developed that. Nathan Oakley is another one. Austin Witsit. You guys know Witsit Gets It?
Yeah, dipshit. Yeah, I typically
Yeah,
call him
he's a
dipshit.
Flurf Daddy. He's a Flurf Daddy, and actually comes up with original thought. And then you have your second tier flurfs, and those are the people that rather, they have a flurf daddy and they sit down and they kind of faithfully reproduce that flurf daddy's arguments.
Yeah,
So if you look at, somebody like Caleb, his flurf daddy is Eric Dubay. All right.
that makes
And he
sense.
literally repeats the arguments that Eric Dubay made. He does also use a little bit of Austin Whitsitt. Ditrh Weiss, is kind of like a an Eric Dubay devotee. His big claim to fame is he came up with this little app for your phone. But those are the second tier flirts, and the third tier flirts, which is the lowest tier and the most common, are the ones that just watch videos and put out a mixtape of derp. And it really has no. They always ask the same questions, and they never listen to any of the answers. So I already know all the arguments, the questions. I know the tobacco script. I know the 5 characteristics of science denial by Lee McIntyre. I already know their arguments, which is why Caleb didn't present any problem the other day. I've already heard them all.
Yeah, they
So
are as predictable as they are stupid. Do you know who's the
yep.
guy? Who's the guy that in all the thumbnails on YouTube he's wearing sunglasses that show the flat Earth?
Nathan Thompson.
Yes. So I don't know. Do you know who Kent Hovind is?
Oh, yeah, I know who Kent Hovind is.
Yeah, he's on TikTok now too, apparently. But
Mr.
have you?
Scientist that wears a white lab coat he didn't earn. That guy? Yeah.
Yeah, yeah, scientist. He has a PhD, but it's in like theology or something. But have you seen
Yeah, he went
him?
to a Bible college in a mall,
Yeah,
to
yeah.
be honest with you.
Probably an unaccredited one. Have you seen him do his whack and atheist with the SpongeBob thing?
Yeah.
Nathan Thompson or Thomas, whatever, he does that same thing, but I don't know who did it first. So it's funny because I wonder who's you talked about that they just copy other people. They have a daddy. So I don't know if Thompson's daddy is Hovind, who, for as stupid as
Yeah.
Hovind is, he doesn't think the Earth is flat. But it
Yeah.
would be funny if they were stealing his argument. But I mean, either way,
They
it's
did because Hovind's been doing that for years, and I've never
okay.
seen Nathan Thompson do it until you just told me about it.
I've only seen him
So
do
I
it.
don't think he developed it.
I saw him do it once. I was watching a modern day debate video the other day, and it was like a 3-year-old video. So
Hmm.
that's what I saw. Um,
Yeah, Hovind's been doing it for years.
yeah, he's been doing it like since the '80s.
Yeah.
Unfortunately, well, he
Well,
took
if
a
you
he
find
took a
something
brief
that
stint
works,
to serve
stick
a
with it,
jail
man.
sentence, so that was nice. We had a nice break.
Well, yeah, that's his personal life. Let's leave that out of it.
We can do that. I don't really
Yeah.
even want to talk about the guy because he drives me crazy. Um, so I figured what we could do here is I don't know how long this will go for, but I figured I'd want to have a conversation about how you deal with flurfers. And like what I want to see if I can talk to you about is debunking some of their new claims because you've probably noticed they now try to sound smart by saying things
You
like
found new claims?
well, I this stuff like the toroidal plane of inertia and we see in Euclidean geometry and like bullshit like that. I never heard that stuff
Hyperbolic
years ago. It's
geometry.
more recent, I feel like.
Yeah. Well, one of the quests that I have is always, are there any new Flurf arguments out there? Now, toroidal fields go back to Whitsitt.
Yes.
The hyperbolic geometry of sight. Somebody found an article, from years ago about it in neuro-ophthalmology. All right. Do you know how we see?
Well, I mean,
What do we see with?
I know how a retina works, but the light coming from us travels in straight lines.
Yeah, but the bottom line is we don't see with our eyes.
Oh,
All right. We
interesting.
see with our minds. We see with the back of our
Right.
brains.
Yeah.
The eyes are simply photoreceptors. And then everything is integrated in our head, flipped upside down, because originally it's upside down.
Hmm.
It's flipped upside down, and that is the vision that we perceive. So, the shape of our eyeballs has nothing to do with it. That's ridiculous.
Yeah, I mean the fact that cameras have flat photon sensors and our eyes have rounded ones, yet photographs look like what we see with our eyes. So the shape couldn't possibly matter.
No.
But like in your experience, what argument are they even trying to make when they say that? Are they trying to say that um well, no, you globies, you just don't understand perspective because our eyes are curved and that's tricking you into thinking that I just don't
that they
even know what
started
they're
to.
trying to say,
Their argument is that because we see in hyperbolic geometry,
which we don't.
which we don't,
Right.
but because our eyeballs are round and the back of our eyes have hyperbolic geometry on the retina, we're somehow fooling ourselves into having an illusion, or we're imagining a globe on a flat earth. And as a result of that, every different way that we measure the surface of the earth, even if we measure it with the odometer, the distance between 2 points, and apply the Haversine formula, every measurement comes out to the same radius. But they're saying somehow, because our eyes are different, even if we're not using our eyes that way, therefore it's an illusion. It's one of these arguments. There are 5 characteristics of science denial: cherry picking, conspiratorial thinking, promotion of fake experts over real experts, poor scientific logic and deductive reasoning, and an inappropriate expectation of perfection from science. And that is a good example of characteristic number 4. It's just poor reasoning. And it's also an example of number 1, cherry picking, because they found an article that said hyperbolic geometry and therefore flat earth.
Yeah. Well, I don't know what you would call this, but I think that tactic is really just obfuscation, right? Say a bunch of stuff to make it sound like that you know what you're talking about. And because you're using big words, but it's all nonsense, the person you're talking about, like, you have no choice but just to throw your hands up a lot of times and be like, I have no idea what you mean. Now all of a sudden that makes them sound like the expert, and you can't even comprehend what they're saying.
I could sit down and start spewing off Latin names of bacteria and mentioning community acquired pneumonia and third generation cephalosporins. And you hear the words that I'm saying, but they make absolutely no sense to you. But if I say it with conviction, I must be right. And one of their biggest tactics in the flat earth is to sit down and try and find something that you don't know. And then they try and become the expert on it. They're trying to find some part of your knowledge. So classically, what you'll see in the flat earth is, some high school kid, one of your students maybe, will get on a flat earth site and say, I know that the earth is a sphere. I know that the earth is spinning, rotating. And he'll go on the site and he'll be warmly welcomed. And then they'll sit down and say, oh, so you think the earth is rotating? So how exactly would you prove that it's the earth rotating and not the stars?
Because we have a
6 years
kinematic
ago,
equivalence.
yeah, yeah, but how would you differentiate it? So 6 years ago, I might have had some trouble answering that question because it never came up. However, in that time, you run into somebody like me. Well, weight changes by latitude is one. Fiber optic laser ring and laser ring gyros is another. Okay, there's a lot of things that you can do. The characteristics of shadows in sunrise and sunset. Um, the fact that a mechanical gyro compass works depends on the Earth rotating. It does not work if the Earth does not rotate, and they do work. Therefore, the Earth is rotating. They don't know these arguments, and as a result, they get pounced on by about 6 flat earthers.
Yeah.
It's called a dog pile. And then they're either booted off or they quit because they can't take it anymore. And when flat earth wins again, we defeated the globe. But they prey on people that don't that are not subject matter experts, which is why the other day, that's why it turned out the way it did with Caleb, because he would try and ask these questions and I knew the answer to them. And then I'd ask him follow-up questions that were directly related to it, and he couldn't even respond. How many people can you go to and say, what's the difference between Euclidean and hyperbolic geometry? How many people can actually answer that question and then explain that it has to do with this? It's the surface that the triangle's on. It's not the triangle.
Yeah.
And when you answer it, it kind of flabbergasts them a little bit, and they try and find something else to get you on.
Yeah, they
And then
changed
the
the
nervous
subject. Yeah.
laughter, then the nervous laughter starts and they start talking over you some more and interrupting you, and then they throw you off the show. That's the way
Or
it
the
typically works.
condescending tone. Or
Oh yeah.
here's I have a specific question for you. How do you deal with it when they say, you talked about the gyroscope or whatever, the way it processes, it won't do that unless the earth is spinning. They'll say, "But Bob, that's a begging the question fallacy."
Okay. Well, why do you okay, so whenever they ask me that, I say, okay, well, you've asked other people's question. You've asked other people that same question. What did they say? Why do you think that's wrong? And try and find out the reason they think it's wrong. Now, that's when they fall on their face because they expect you to oppose them. What you do is you bend into them a little bit and say, no, you may have a point there. What do you think is going on here? How do you think a gyrocompass works? And then they start talking to you about Mercury and the gyrocompasses and magnetic toroidal fields. And then you bring up the fact they don't use Mercury in gyrocompasses anymore.
Mm.
And, I mean, little things like that. How does that explain a laser gyro? An inertial reference system on an aircraft has 3 laser gyros bolted at right angles to each other to the structure of the aircraft. And that's how they navigate. These things work. So now you got to explain how they actually work. Okay, the other thing you can do is say, hey, let's just for the sake of the argument, say the Earth isn't a sphere. What shape is it? Do you have any evidence of that?
Well, some of them say
And
it's an
that kind of knocks
infinite
them off.
plane. Some say it's I don't get
Right.
how it can be in a dome and yet it's an infinite plane in all directions. I mean, I guess that can be true if the firmament just is there, whatever the hell that thing is.
I wonder what accelerates meteors then. How do they,
Yeah,
if they fall from the dome, how do they accelerate so fast they burn up? What's the force behind that?
electrostatics is what they tend to say nowadays.
Oh, well, we can measure electrostatics. Do you have any papers that I could look at to see the power of the electrostatic field that would accelerate meteors to railgun velocities? I'd really like to see this stuff.
Yeah, when you that's something I have tried with them, and I've seen other people try it with them too. Just say, look, let's just assume that I'm wrong. Tell us how it works under your model. And some of them say, we don't have a model. I'm not the one. I hate it when they do this. They say, I'm not the one making the claim. You are. It's like, no, you claim you don't believe that Earth isn't a globe. I mean, you do. You believe Earth isn't a globe, but you have the positive claim that Earth is flat, and they pretend that they have no burden of proof or anything like
Oh,
that.
yeah.
It's mind numbing.
Well, you can't have a model because a model's testable.
Yeah. Well, I mean, they tend to
That's
have.
why, no, that was a quantum eraser thing. Never offer a model because then they can test your model and prove it wrong.
Yeah. They tend to. So some of them say, like, there is no model. They'll say there also is no globe model, which is stupid because the thing about the globe observations is they are consistent with each other. The Coriolis. This is the great thing about science and scientific theories is they unify an enormous range of observations. So just if we just go with that the Earth is a sphere, that does explain why the night sky rotates clockwise and counterclockwise depending on where you are. It explains the geometry of where the sun is depending on your latitude and where the North Star
And
is
in
and why
fact,
you
this thing works.
and how a sextant works and so many other things. Now what they do is, they'll come up with an explanation for something, but it's always contradictory to other claims. Like I saw a during a debate, I saw a flat earther say it was Nathan, the Thompson or Thomas whatever guy. Um, it was something about like why does the sun disappear from our line of view? And they say it's getting farther away. And then, well, somebody asked, we can see farther when we go up higher. That confirms the idea that Earth is a globe. And his argument was, no, you're going up where the air is thinner. And so, because the air is thinner, light can travel through the atmosphere farther, so you'll see farther. And I thought, hey, that's actually kudos to you for coming up with that on the spot because it's not terrible, right? But it contradicts a separate observation. The sun is at a, if we assume Earth is flat, the sun is at a consistent altitude. Yet if you map, night and day on a flat Earth, where you're gonna see that Terminator line or whatever, and you're gonna find that the sunlight toward like whatever the North Pole, that's gonna be a very short line, but it extends all the way to parts in the southern hemisphere much farther than that.
Oh, it's easy to explain.
So it's completely contradicted. Like that explanation is totally contradicted by the fact that the sun extends its visible light in different distances over the flat
Well, their
earth.
argument is that the ice wall acts like fiber optics and transmits the light around. I'm not
Oh.
kidding. They tried that.
No, I know, yeah. Yeah, I've seen.
And, the biggest problem that they have is that if they think of it, it must be true.
They are
And they
very
don't
arrogant.
realize that I don't want to know what you think might have happened. I want you to demonstrate what did happen. So, for example, with the moon landings, uh, we have a lot of documentation, a lot of warrant to believe the moon landings occurred. The burden of proof that you have is that you have to show me that Neil Armstrong was in Hoboken, New Jersey on July 20th, 1969. He was not where they said he was. You have to show me where he actually was. That one more orbit flight that went pole to pole and circumnavigated the world. You have to show me that's in a hangar in Palm Beach, Florida, and not over the South Pole in order for your claim to have any validation, because there's too much evidence to the contrary.
Yeah.
You have to show me something that's overwhelmingly conclusive that it was fake.
Well, aren't you forgetting that they can just lean back on an argument from ignorance and just say you can't go to space because the temperature in space is higher than the melting point of metal? That's an extremely stupid argument. The Van Allen belt
Yep.
radiation is too dangerous. You can't have an
Yep.
atmosphere next to a vacuum. All very
Yeah.
stupid and
Violation of the second
disprovable
law is one
claims.
of my favorite ones.
Which one is?
The violation of the second law of
Oh,
thermodynamics can't have a vacuum next to an atmosphere
yeah. Well, it
without a
just,
container.
like I said, they don't even believe that because the same reason you supposedly can't have a vacuum next to an atmosphere would be the same reason that you can't have an atmosphere that has partial or that has pressure gradients. When you open a can, it goes, Shh. Why? Because it's going from high pressure to low pressure. They
Hmm.
know that the atmosphere is much thinner. The higher, like they've sent weather balloons up there. They know this. Why isn't the air rushing upward all the time to equalize in pressure? Because that's what it would do if assuming their model is true. And if you can have the atmosphere at 0.01% the pressure or density at sea level, which they don't even deny, then why can't it be basically zero at some point? And
Well,
they have no answer for that.
I just asked them at what altitude does the pressure gradient go to zero?
Yeah. Well, they'll say at no altitude, but it goes to
Okay.
point zero 0.01 or 0.001. That's fine, but it's just they're obviously not thinking about it, so let's
No.
not be too generous to them.
Last night and today I measured the velocity of the ISS. It's going around 7 kilometers per second. That's not possible in the atmosphere of Earth.
Oh,
And
yeah.
I verified its position is right where NASA says it is. And it's going as fast as NASA says it is. And I verified that myself.
Would that
I
take
track
Oh,
satellites
sorry.
in space all the time. They're right where they're supposed to be.
Would it take an insanely long amount of time to explain how you do that, or is it fairly simple?
It's very simple. Uh,
I would like to hear it because I have no idea.
there is a ham radio repeater on the International Space Station. So what happens is ham operators like me will call up to the International Space Station on one frequency, 148.5, and then that repeater sends it back out on 437.8. That's the transmission frequency, 437.8. Now, when I first receive it 2,200 kilometers away as it's coming towards me, I don't receive it on 437.8. I receive it on 437.81. And then as it comes close to me, the Doppler shift occurs and that frequency starts getting closer and closer. When it's at the transmission frequency of 0.8, that's station passage. And then it starts going below 0.8 as it goes away, just like an ambulance siren.
Oh, interesting.
And you can use the Doppler shift of that signal to calculate the speed of the object that's emitting that radio frequency. And it's 6.8 kilometers per second by my calculations. Now remember, there's a little trig you have to add in that too. That's just the basic calculation. But you have the slant angle as it goes over your head. That changes that a little bit. It makes it look a little slower. And it's also, if it doesn't go right over your head, you got to account for the azimuthal angle too. So the fact that we can do that with $100 worth of equipment, you know, the television antenna that I'm using, I got for $10. There's a little coax cable and a software-defined radio and some free software. That's all it takes to measure the velocity and the position of the ISS. But they won't do it.
Well, I mean, I like to think that I'm not a dummy, but I would have never had even the first clue that you even can do any of that stuff. But that is, I mean, not to be too generous to them because they don't even try to prove that
Yeah.
what they believe in is true. It's pretty much all just like they make up a bunch of gobbledygook, but it's all about just
Sure.
arguments from ignorance that the globe can't work because of
Yeah.
X, Y, or Z.
Well, tomorrow morning I'm releasing a video at 8:30, so make sure you get up at 8:30 Sunday morning to watch this thing, Eastern time. But
Oh,
it'll be
that's
out.
5:30 in the morning for me.
Yeah, yeah, it's well worth getting up. But I'm showing the passage of the ISS from the live stream last night,
Oh,
so
that'll
you
be
can
awesome.
actually see what it looks like.
That's cool. That's cool.
It's a
Um,
6-minute video. It's worth 6 minutes of your life.
so we've kind of already touched on like the tactics that flat earthers use, but are there any like particular ones that you want to like, mention again or like say this is what they're doing, beware of when you see or hear this and here's how you can deal with it?
Well, that's kind of what I'm going to be doing a lot of on my channel. I'm going to be analyzing the things. So what you need to do is you need to hear the arguments and the approaches and say, oh, Bob told me about that one. I know how to deal with that. So generally, one of the things that they will do is word salad. Like when Caleb the other day said, oh, well, don't you know that we see in hyperbolic geometry? And you look at it, you just sit there and you pause for a second and you say, hyperbolic geometry, interesting. Why do you think it's hyperbolic geometry? And then, you take a moment. They want to go from subject to subject to subject. They want to dogpile you with things. If you ever want to take a moment, listen to Nathan Oakley and have him talk about Walter Bisslin's affirming the consequence globe fallacy, Earth curve
Yep.
calculator, using
Yep.
imaginary refraction in space that can't exist.
Yep.
And he throws that out. It's a practice script that they have. And the purpose of that is to try and divert your attention to make you think about these other things. So what you do is you sit down and say, okay, we're going to talk about Walter Bisslin's then. You take the very first thing that they say, ignore the rest of it, and only respond to the first thing they say. And that's one way to keep them on task and prevent them from derailing the conversation. You notice lots of times when you talk to flat earthers, they just try and dogpile you with 12 different claims at once. Well, which one do you take? You take the first one and ignore the rest. That would be my advice. That's the first thing that I would do going into one of these things. Now, the other thing is, you can do content rebuttal if you know the subject.
Yeah.
All right. If you don't know the subject, ask them why they think that way. Ask them why they think that the Gleason map is a true map. Doesn't it have some problems in the southern hemisphere? Doesn't the patent say that it's a globe, a projection of a globe? The Gleason's map is just a timetable. It's a time calculator. That's all it is.
Hmm.
So,
Yeah, I, I've heard a lot of flat earthers say something to the effect of pilots are trained on flat maps, and maps are flat. Why do you think that is? I was like, because paper is flat, so is the earth. Like, that's your argument. And then they tend to say stuff that's just a flat out lie. And without knowing, but it's going to be, it's extremely esoteric knowledge. Like, did you know that according to the 1986 NASA documents to show that whatever the training module they
yeah,
had for the
I've read
digital
'em.
program assumes a flat, non rotating disk or whatever?
Yeah, well, you see, instead of letting them go through that, you say, "Yeah, I've read them. What's your question about them?"
But if you haven't
You
read
know?
them,
Yeah. Or you can't go to Antarctica. Great. What section of the Antarctic Treaty is that? It's 6 pages long. Here, I've got a copy of it right here.
yeah,
Tell
it's
me
really
which of the
short.
14, tell me which of the 14 sections of the Antarctic Treaty says you can't go below the 60th parallel.
Yeah, I talk about that in this book I wrote that's coming out soon. It's just
Yeah.
a series of anti-scientific claims, and that one's in there. And yeah, I read through the treaty. I was like, the word ban doesn't appear anywhere in it. I think the word prohibit occurs twice, but only adjacent to like within paragraphs talking about nuclear testing. Um, yeah,
You know what the
nothing.
Antarctic Treaty is?
Sorry.
You know why we have the Antarctic Treaty?
I thought the idea was for it was it kind of was born out of the Silent Spring
International
era, like
Geophysical.
new environmentalism, and people were just kind of sick of the Cold War and stuff like that. And so we thought, let's just leave
Oh,
this
they were
place
real happy with the
alone.
Cold War. World War II had just ended. Now, after World War II, we sent a carrier task force down to Antarctica and put everybody on notice that if we wanted it, we were going to take it. And we were the only country in the world capable of doing that. And to prove it, we did, we sent a two task force down there under Byrd. So then they had the International Geophysical Year where everybody, exchanged scientists and sang kumbaya around the campfires and wintered over in Antarctica at each other's camps. And then we kind of got to thinking, we're going to have a war down here because this is very strategic, it's mineral rich. We're going to have some issues. And if we don't do something about this, this is going to be the start of World War III. So we all got together and said, look, none of us want to do this anymore. Let's just make it basically a scientific preserve. We will not militarize it. We will all use it cooperatively. We won't claim parts of it because if anybody's going to be claiming parts of it, we're going to do it. And we're the only ones that can.
Yeah, at that time.
So
So it
why
was
don't we all cooperate and play nice?
it was
That's
signed
what
in
the
the
Antarctic Treaty came from.
it was signed in the early 50s then, or
Signed in 1960. It was developed in
okay.
1959 and originally signed in 1960.
Okay, so my timeline about Silent Spring and all that was way off. All right, good. I
No,
learned
no, it's
something.
it's not all that bad. But yeah, but basically it was designed primarily to keep us from fighting over Antarctica. We figured we've screwed up the rest of the Earth. Let's not do it there. Come on, guys. And that was the initial. That's kind of the way that we approach space as well. We didn't claim the moon. We don't claim space. We cut off national airspace at the Kármán line at 100 kilometers so that we don't have to shoot down each other's satellites. There's a lot involved in all of this that a lot of people don't think about. You fly an airplane over somebody, it gets shot down. You fly a satellite over them, well, technically we should shoot it down, but let's have a convenient excuse not to, you know? Because if we shoot down, satellites on a regular basis, people are going to get mad. Plus, by having the satellites up there, that means that we can have our satellites over their country and not get them shot down. We have more satellites than they do. That's
Yeah.
still a win-win for us.
Yeah. I know so little about this, but there's an interesting question about like what do we call space law? Like, is space currently governed by the rules uh, that we adopt for like international waters, or
Mhm.
what? And what should we do in the future? So I know there's interesting conversations that are happening around that.
Well, when we can start getting resources out of space, asteroids, hydrogen-3 water on the moon, it may get a little bit more interesting, but right now it's kind of viewed as high seas. Anybody's in trouble, you do everything you can to rescue them. You know, you wave at each other as you go by,
Yeah,
that sort of stuff. We try and advise them of when we're doing things. They try and advise us when they're doing things. It works for the most part.
yeah.
When we launched Apollo 11, there were Russian spy ships off of Florida. And basically, they went out there and, they were really worried that the Russians would interfere with the communications. And basically, they went out there and said, look, here are the frequencies we're using. Don't screw with us. You know? And they didn't.
Yeah.
So,
Well, we're currently serving basically a proxy, or we're engaged in a proxy war with Russia while collaborating in space with Russia every single day.
yep,
We
yep.
that's pretty fascinating how two groups that are spending billions of dollars to oppose each other's interests are united in a common interest in space.
As Kennedy said, space is hostile to us all.
Well, that's very true. That's very
And
true.
that was a rather profound statement that he made at Rice University. And that was part of his "We Will Go to the Moon" speech. Space is hostile to us all. We need to work together to explore and expand into it. It doesn't need to be a new theater of war.
I have a question. I don't know if you know the answer to this. I suspect you probably do, though. Um, I know that the way we measure our distance to the sun is to, well, the first way it was done was to, observe a transit of Venus from two different places on Earth. But I couldn't possibly explain to somebody how you actually do that. Do you know how that measurement is done?
Well, it was done. There were several ways that it was done. Initially, it was done in terms of the distance to the moon by Aristarchus of Samos. And I've got two videos on my channel about all of the geometry that he developed 2,300 years ago that actually works. The only reason he came up with the wrong answer is his measurements weren't accurate enough.
Hmm.
So we can determine the distance to the sun that way. The second way we determine the distance to the sun is that they assumed that Venus was the same size as the Earth and used the angular size because they knew the relative distance between Venus. Well, they knew that Venus, I think, is what, 0.72 or 0.78 astronomical units from the sun, and we're 1 astronomical unit from the sun. So you can use that distance between Earth and Venus to kind of get an idea based on angular size about how far the sun is. And it was actually pretty accurate. But that was based on a very lucky guess that Venus and Earth are indeed about the same size. Then in 1761, as I recall, they actually tried to do what was called the transit of Venus, which was developed by Edmund Halley. And the transit of Venus says that Kepler says that Venus is this distance from the sun. And if you look at the sun and plot where Venus crosses the sun from two widely separated locations, you can get the parallax of Venus and use that to calculate the distance to the sun. They tried to do it in 1761.
It's cloudy, wasn't it?
Unfortunately, what?
It was cloudy, wasn't it, on one of the islands?
No, there was a war, a
Oh,
big war. And it got to the point that the French Academy of Science and the British Academy, even though they were both at war, the British Academy tried to get letters from the Admiralty giving the French ships safe passage to do these measurements, and actually got them to the French. And then the French went through it, and then an English warship stopped them. They said, "Look, we've got this letter from the Admiralty. And they said, we don't care. Screw you. You're
Oh man.
French. So it didn't work out very well in 61. So in 69, 8 years later, when they had the second one, they had an enormous effort where they sent out 140 some odd teams, including Cook to Tahiti. And they also sent a couple of guys named Mason and Dixon to measure the transit in South Africa. And when they did such a good job there, they said they had another job for them to do. So these are the guys that
Yeah.
came up with the Mason-Dixon line.
Yeah.
But they went ahead and they calculated it based on the transit of Venus. And the math is pretty complex, but it's not beyond a good high school student.
Okay.
You know,
It's
if you
probably the
got a
kind of thing
student
where you
that's
want to
good
have
at
like,
math in high school, he can do this.
yeah, it'd probably be best served if we had like, diagrams so we could draw it out, and we're not really set up to do that exact kind of thing right here right now, but that's okay.
Nope.
That's okay.
I'll put a video out on my channel this week for it because I've done one and I'll just put it out. They actually did it. A guy did it with a friend. He was on top of the parking lot at Princeton University, and his buddy was over on the observatory in Hawaii. And they both did the transit of Venus at the same time, and they actually did the full calculation and got within 50,000 kilometers of the actual distance.
That's really
So it was a
good.
pretty neat trick.
To do it back then, when you don't even have calculators or anything, I
Nope.
just it boggles my
Took
mind
you.
how much of a genius people like Halley had to have been, and Kepler. Like, I don't understand how just watching something go across the sky, how you can extrapolate that it's moving in an ellipse from that. It's just
Well, I
mind-boggling.
measure the orbits of what I do with the observatory is not just take pretty pictures. I'm not really much of an astrophotographer. I measure asteroids and comets for the Minor Planet Center. So I take observations of these asteroids and literally calculate their orbits
Oh, that's cool.
and their orbital elements. And I use software for that, but that's what it does is simply having observations will allow you to calculate an orbit accurately and one that's predictive.
It's a little bit off topic, but I can't really think of anything relating to flat Earth anymore. But um, what did you think of? Like, what were your conclusions basically after the Oumuamua phenomenon? I seem to remember they
You
thought
mean
it
the
got,
alien spacecraft?
yeah, yeah, because they thought it sped up, and maybe it did a tiny bit as it was leaving, but I thought I heard at one time that was just there were just gases, like it was outgassing, and that was pushing it along, but there wasn't anything otherwise super special about it.
You know, one thing about flat earthers is they like to talk about relativity, and my counter to that is always, okay, would you mind being so kind as to tell me the three laws of Newtonian motion in order correctly? And if you can't tell me the laws of Newtonian motion, I don't want to hear your opinions on general relativity. If you don't understand basic motion and gravity, I don't want to hear them. So the issue that you ran into with that is as it got closer to the sun, it would make sense to have some outgassing as it warmed up. Maybe some ice came out. We changed the orbit of an asteroid just by hitting it with something the size of the refrigerators we had in college, basically.
Yeah, dart. Yep.
But things don't move unless forces act upon them. So the question is what force acted upon it? Now, if it made a 30-degree course change and then turned back on itself, I'm going to try and figure out how I'm going to meet our new reptilian overlords. But if it just kind of nudged a little bit and there's a reason for it, I'm going to go ahead and accept that. Um, you know, when ships are maneuvering, they don't generally maneuver just a fraction of an arc second. They make a turn, and I think that's what we should look for. I don't think there was much of a turn.
Yeah. Yeah, from what I remember, it's been a while, but people thought that it sped up as it was leaving, and so then that was like, well, what what would be the explanation for that? But
Yeah.
um I I don't know. I'm kind of running out of ideas. What's your favorite argument to hear just because of how dumb it is and how easy it is to dismantle and watch them panic? For me, it's water always finds its level. That's my favorite.
It looks flat to me.
Oh, interesting. I mean, it kind of
Yeah,
does.
it looks flat to me, therefore it is flat.
Yeah, I don't know what fallacy that is. That's kind of an argument from ignorance, I guess. Not exactly,
I
but
don't play, that's one thing they used to do over on YouTube is try the fallacy arguments.
yeah, I think
And my
it's dumb.
response to that is, would you be kind enough to show me one single peer-reviewed journal article that says a scientific observation or theory was disproven by calling it a fallacy?
Yeah. I said that in a video I uploaded maybe like a week ago or something. I was like, look, let's cuz what Oakley does in his unbearable tone of voice is he says you're affirming the consequent and stuff like that. Um
So what?
and yeah, well it's like okay, but that doesn't mean that it's not true. It means that it
That's called the fallacy.
a fallacy
Simply,
fallacy, yeah. Yeah, like
simply because, I call it the even a blind squirrel gets a nut sometimes fallacy.
that's funny.
Because occasionally you can use a fallacious argument and still come to the correct conclusion.
Yeah, so I think the example I gave was like with affirming the the consequent or whatever. Like if it's raining outside, then I will get wet. I am wet, therefore it's raining outside. Now I reasoned that backwards. I started with with the then statement, but that does like if you are wet, raining is actually an excellent explanation for how you got wet. It by no means that what you're saying isn't true. So
You
yeah,
could have technically have just walked through a shower in your house,
yeah.
or somebody could have dumped water on your head. But the fact that it doesn't logically flow that that is the one and only conclusion does not preclude that being the actual answer. You could have very well have gone outside raining. It doesn't disprove that it's raining, as you say.
Yeah, for sure. Um, I think maybe we'll do one more here. We've been going for an hour here, but I saw somebody
I
write
do
this.
appreciate it. I
Oh
do
yeah,
appreciate your help with
my
this.
pleasure. It's been fun to do. Somebody in the comments saw, and I've seen this argument crop up before. Um, in order to, like, for example, when we say to them, look, you can take measurements of Polaris and see that the geometry doesn't work with a flat earth or whatever, anything like
Mhm.
that. They'll say, but you're using yeah, the cowboy hat, that was great. Oh, I got one now too. Um, they'll say you're using a flat earth model to prove the globe because you have to assume it's flat to have triangles, to do the trigonometry or whatever.
What angle do you measure with a sextant?
Well, you measure to me
You
like my
measure the angle here on the sextant between the index arm and the body of the sextant. That's the only angle that you're measuring.
yeah, you
Has
don't
absolutely nothing to do with the ground.
yeah, you don't need a base. You can make an angle with a point technically.
Yeah.
Yeah.
And there are how many angles am I measuring? One. How many angles does a triangle have to have? Three. I'm only measuring. Oh, now they're screwing with us.
Yeah, kind
I
of.
like that. I got to learn about these things on TikTok.
It's a
But
different world, yeah.
yeah, but you know, not knowing how the basic instrument works, or not knowing how a gyro compass works, or not knowing how having to ask me how to spell the Haversine equation and then telling me my understanding of it's wrong, that just doesn't fly. I'll show you how a sex. I'm more than happy to show you how a sextant works. We'll do a sighting together. I'll walk you through the math and make sure you understand it and why we do it that way. But don't tell me that I'm wrong unless you can take your sextant out and do a better job than me. I can get within 2 nautical miles of my position, and I'm an amateur. So The last flat earther I saw tried to do it with flat earth math, got over 1,500 nautical miles wrong. He thought he was in Baja California, not realizing that traditionally shipped time is either UTC or it's generally wherever the last port was. So they were using California time while taking an actual sextant measure in Hawaii. And we can get these things within 5 miles or so. That we can, an amateur can do that all day long if they know what they're doing. The pros get it down a lot further than that. But these flat earthers don't have the first clue what they're talking about with it. Yet
No.
they want to presume to be the experts on it and tell us that it means the earth is flat. But you can actually, with the Eratosthenes experiment, you can make the prediction of the shadow on the sticks using both the flat earth and the spherical earth.
Yeah. You just have to
Just like I
do
did.
multiple measurements.
Yeah, I calculated, when I did the horizontal across my lake, I said, on a flat earth, this is what I'm going to see. On a spherical earth, this is what I'm going to see. This is my margin of error. I have to be better than that, or I'm going to consider it unproven either way. Guess which one it matched? The spherical earth.
Oh.
By a ways.
That's excellent. Yeah, what I would my challenge would be for these yahoos, like we know so far ahead of time, like there was an annular solar eclipse back in October. We knew that was going to happen years ago, right? My challenge to them would be predict the next time Mars goes in retrograde, or predict any upcoming eclipse and show your work. Because the only way you can't do that with a flat model, which is like a weird neo-Tychonian model, because there's no mathematical regularity with it. It's totally chaotic. The epicycles don't work for anything because of the fact that these things are going around the sun.
Well, they don't understand the basic meaning of words. They seem to think that geocentric just means observing the solar system from Earth. And I said, no, geocentric means everything orbits around Earth. That's what geocentric means. Well, no. Well, then how do you explain the fact that Venus orbits around the sun between us and the sun? Well, no, those planets orbit around the sun, but the whole sun itself orbits around us.
Yeah.
So therefore, geocentric. No, that's not the way it works, Sonny. All right. I mean, I'm sorry. That's just not it.
Oh, don't be sorry.
They don't.
They don't deserve it.
Well, that's why I'm not going to spend a lot of my time with them here. I'd much rather do the science and the fun things.
Well, that's
Dealing
good.
with flat earthers is kind of boring. I have not run into one here yet that's better than a second tier flurf. They're pretty. Like I said,
they're very lowbrow here. Yeah.
I don't really see any top tier flurfs on TikTok. Do you know of any?
No. I mean, Caleb's more popular here, but I mean, he's garbage. He's just
popular, but he's a second tier at best.
Yeah, kind of like.
Is there anybody here that's top tier? I mean, Dave Weiss is a second tier flurf.
No, I haven't met any. The ones I've talked to are they're just so. I got a very long playlist on my channel with flat earth stuff. If you want to laugh, like if you have nothing better to do, if you're waiting for a connecting flight or something, open that up and just like, oh, geez, you'll see some very, very bottom tier stuff on there. My camera died, so I think at this point that's probably enough for the session. We'll try to do it again sometime. I'll try to come up with an interesting idea for doing it in the future or whatever, or we can just see.
When you join me one night, we'll if I ever get a clear sky here, we'll play with a telescope for a while. We'll look at satellites in orbit.
That would actually
which we find to within an arc second, right at the place NASA says they are.
That would be really great. Yeah, that
we
would
can
cool.
do stuff like that.
Yeah, just hit me up. I do these live streams every Sunday, Wednesday, Thursday at 7 p.m. Pacific time. So,
all right.
That doesn't always work
Well,
for
thank you
everybody
very
else,
much.
but
I do appreciate you having me up.
oh yeah, you're very welcome.